Find the differential coefficient of y equals 4x squared plus 5x minus 3 and determine the gradient of the curve at x is equal to negative 3. Find the differential coefficient of y equals 4x squared plus 5x minus 3 and determine the gradient of the curve at x is equal to negative 3. So I welcome you once again to my channel, and as we have been doing it all the time, today we are going to solve this question. Find the differential coefficient of y equals 4x squared plus 5x minus 3 and then determine the gradient of the curve at x is equal to negative 3. So before we move on with the solution, if you have not subscribed to the channel yet, please subscribe. Okay, please subscribe. Okay, so the solution. So the function is what? Y equals 4x squared plus 5x minus 3 and we are to differentiate this. Okay, 4x squared plus 5x minus 3. Y equals 4x squared plus 5x minus 3. Okay, so we are going to take each term and then differentiate it. Okay, all right, so let's take the first term, that is 4x squared, and then differentiate it. So we have d over dx of what? 4x squared. So that means we are differentiating 4x squared. Okay, all right, so 4 here is the coefficient of what? X squared. Okay, and we are to differentiate 4x squared. Okay, all right, so this is how we do it. We multiply the power by the coefficient, which is what? 4, and then we subtract 1 from the power. Okay, to differentiate 4x squared, first we multiply the power by the coefficient, which is what? 4, then we subtract 1 from the power. Okay, so this is going to be 2, which is the power multiplying the coefficient 4, x raised to the power 2, then we subtract 1 from the power. Okay, so we have 2 multiplying 4, x raised to the power 2 minus 1, and this is going to be what? 8x. So to differentiate 4x squared is what? 8x. I hope you understand. So let's take the second term, which is what? 5x. So to differentiate 5x, that is d over dx of 5x, that is also going to be the x here is raised to the power 1. Okay, any number raised to the power 1 is the same number, so x raised to the power 1. And I said earlier that we multiply the power by the coefficient. Okay, so since x is raised to the power 1, 1 multiplies 5. Okay, then we subtract 1 from the power, which is what? 1. I hope you understand. X here is raised to the power 1. Any number raised to the power 1 is the same number, so x raised to the power 1 is the same as what? X. And I said to differentiate, we multiply the power by the coefficient, then we subtract 1 from the power. Okay, so since x is raised to the power 1, 1 multiplies 5. Okay, then we subtract 1 from the power, which is 1. Okay, so it's going to be what? 1 multiplying 5, x raised to the power 1 minus 1, and that is going to be what? 5. Then we take the last term, which is what? 3. So to differentiate 3, that is d over the x of 3, that is going to be what? 0. So therefore dy over dx is equal to 8x plus 5. dy over dx is equal to what? 8x plus 5. So to differentiate the function y equals 4x squared plus 5x minus 3, dy over dx is equal to what? 8x plus 5. I hope you understand. Okay, now we are to determine the gradient of the curve at x is equal to what? Negative 3. We have to determine the gradient of the curve at x is equal to what? Negative 3. So what we are going to do is we will substitute x is equal to negative 3 into the expression 8x plus 5. 8x plus 5. We substitute x is equal to negative 3 into the expression 8x plus 5. So that is going to be 8 multiplying negative 3 plus 5. X is what? Negative 3. So we have 8 multiplying negative 3 plus 5. And that is going to be what? Negative 24 plus 5. That is 8 multiplies negative 3 to what? Negative 24 plus 5. So when you add negative 24 plus 5, we are going to get what? Negative 19. So the gradient at the curve x is equal to negative 3 is what? Negative 19. So to differentiate the function y equals 4x squared plus 5x minus 3, the y over the x is equal to what? 8x plus 5. And to determine the gradient at the curve x is equal to negative 3, the gradient is what? Negative 19. Thank you so much for watching the video, and please don't forget to share and then subscribe to the channel. Thank you.